Now that we've learned a little bit about R in general, let's actually take a look at an actual R session. So I'm running the base R package in RStudio, and so you'll notice that there's several different windows here. So first of all, we have some kind of a basic window for our scripts, and here I've basically already written the script that I'm going to be running, and I'm going to make available a link to this script in the description of the video so that you can take a look at it on your own. In addition to the window showing the R script, there's also some other windows that are shown here. So here is basically our output window. So anytime we run some code, the output that results from that code will be shown here. And then we have a global environment window, which basically shows us any objects that are in our environment. So as we start running some code, more and more objects are going to be shown in that environment. And then we have another window here that basically shows like help files, any packages that we may install, any plots that we make. It shows us our file directory system. It shows us our viewer. So anything that we sort of run in the process of running our R session will be shown here or here or here. Okay, so let's actually kind of look at the script that I've written. And so you can kind of zoom in on that. You can see that I've started by putting some kind of a header at the top of my program. And you know this is a header because this is actually written as an R comment. And in R, comments are basically created by starting a line with either what's called a hash or pound symbol and ending the line with a carriage return, that is pressing enter. And comments are just basically non-executable commands. So they're commands that you include in a program in order to kind of give you a better sense of what information is being presented at various stages of the program. It's a way of kind of documenting your work. And so I start with a basic header, and in my header I've included the following information, just the name of the program itself. This is called detail example rcode.r. Any R script will have a .r extension. I've included the name of the author, the date that I first started creating the file, and the purpose for creating this file. Now you could also add some additional information, like if you're inputting some data sets or if you're creating new data sets with it, that could be some information that you could add. You could add the status of the program, if it's ongoing or if it's finished or whatnot. Any number of things can go in a header, but I do recommend that you include some sort of header just so that you can make sure that you're documenting what information you're looking at, and you can see that really quickly at a glance. Now notice that there's some other kinds of comments I have throughout the program as well. So here I have sort of a large comment indicating that this is the area where I'm going to be setting some pre-programming options. I have some more minor comments here, just kind of showing that what each of these different commands that follow the comment is going to be doing. So you should develop your own kind of style in creating comments. Think of them as sort of like headings in a paper, right? So you can have some major comments indicating the different sections of the paper or the program in this case, and then just some minor comments indicating what you're doing at different steps of the program. Okay, so let's look at our first command here. So this is actually a set of functions that are being run in sort of a wrap fashion. So the first function is the rm function. That's the remove function. And this is basically, this command, when I execute it, will just remove all of the objects that are existing in memory. Now right now there are no objects because I haven't started doing any kind of running any of the scripts, so there's nothing to actually remove just yet. But let's say there was. What would it remove? Well, here you see that this is the ls command. Ls is basically just the list function. It'll list any of the objects that are currently in your environment. I'm going to make an object in R called list that's equal to the contents of all the objects that are created. And then what I'm going to do is going to remove those objects, right? So this is basically just house cleaning. So if I highlight this and I hit the run command, it will remove anything in active memory, and that basically just starts my session brand new. Okay, so next what I'm going to do is I'm going to set my working directory, and to do that I'm going to be using the setwd function. And notice that every function in R basically includes a function name and then some value in parentheses. Now this one also has some kind of value in quotation marks, right? So that's important. And so here what I'm going to be doing is I'm going to be setting the working directory. And what that means is that I'm basically going to tell R which directory I'm going to draw files from and create any new files and put them to, right? So I found a directory path on my file system that has the following location. It's in my C drive in the users directory, in the subdirectory Martin, Documents, Work, Courses, Statistics, New, Detailed Examples, R programs. So what I did is I went to my Windows Explorer and I just copied that and then I pasted it. And the one thing that you have to do if you're using Windows especially is you have to change the direction of these slashes. So by default, they're going to be backslashes. You have to make them forward slashes. Otherwise, R won't recognize them. So this command will basically set the working directory. And then this command, this function, getWD, it will list the working directory. So if I just highlight these commands and I run them, and then we kind of zoom in on our output window, you can see that this is the thing that's listed when we get the working directory, right? So that means that R recognizes that this directory and this set of subdirectories is the working directory. And this is where I'll be getting any files from, or I'll be writing any files to. All right, so let's go back to our script window. And so the next thing I'm going to do is I'm going to bring in some data. And so what I'm going to do is I'm going to bring in an SPSS file. And the way that this works is that we have to bring in a library called foreign in order to read any data file that's not native to R. And so if I'm going to bring in a data file that has an SPSS format, I have to first bring in this library. And so the command itself is library, that's the function. And the name of the library is foreign. Okay, so if I just highlight that and run it, R will bring in this library. Now I can use commands that are found in this library. And one of those commands is something called read.spss. And this command basically, or this function, will read an SPSS file and convert it to an R-readable format. And here what I'm going to be doing is I'm going to actually make that into an object in R. And the object that I'm going to create is going to be called dataset. Now dataset is just basically an arbitrary name that I've picked. But dataset is going to be equal to the value that's going to result when I take the SPSS dataset. Here it's called gss2012.sav. And I use the read SPSS function to open its contents and then put it into this object dataset. Now, there's one other component to this command. Notice that I have a comma here. That indicates that I'm going to be using some options with the command. And the option that I'm going to be using is the to.data.frame option, which I'm going to be setting to true. And what that means basically is that I'm going to be reading the contents of this file, gss2012.sav, which is an SPSS format. Anything with a .sav is an SPSS data file. And I'm going to turn it into what's called a data frame. A data frame in R is a native data structure. And that data frame will be saved in the object dataset. So if we run that, and then we switch to our output window, basically it tells us that R read this into our file. If we go back up here to our global environment, we now see that we have a data set with 1,974 observations and 21 variables. And so that basically worked. Okay, so now the thing that we want to do is we want to look at the contents of the data set. And we can do that by looking at this command. Now the names command basically will just tell us what variables or what names are in our object data set, right? And so we're going to use this names function in conjunction with the data set object. And when we run that, and then we look at our output file, our output, we can see that here are the names of the variables in that file. And so we have variables year, ID, child's age, education, and so on. So also sex, race, region, and so forth, right? So these are the variables that we have to work with this particular data file. Now, I'm going to point something out about R. R will automatically convert certain kinds of variables to what are called factors. So factors are basically just like nominal variables. So in some cases, if you have a data set that has value labels associated with it, like let's say that the variable sex. Sex can have values of like male and female, right? So if R sees that they have value labels associated with them, it'll naturally turn them into factors. Now, it just so happens that my data set actually doesn't have those value labels. I didn't put them in. And so R automatically treats these as numeric variables. But if you're using a data set that does have those value labels, it won't treat it as numeric. And so you may have to convert it. And so here's some code that will help you to convert something that's non-numeric, like a factor, into a numerical variable. And so look at this code right here. So notice that I'm using this asNumeric function. This is what's going to take an existing variable and it's going to transform it into something that is numeric, right? So in my case, I don't have to do this because all of my variables are numeric. But in your case, you may have to change some variables because not every operation that I'm going to show you throughout the rest of this video works on non-numeric data. So if you get an error that says something like, this operation doesn't work on numeric data, you first have to transform it. Okay, so one thing about R is that it uses certain kind of naming conventions to refer to variables within data frames and other sorts of objects. So notice here that I have the name of the data frame that I've arbitrarily chosen, dataset, and then the name of one of the variables, sex, separated by a $sign. That's how R knows to refer to a particular variable in a particular data frame. You have to make sure you separate them with this $sign. And also note that R is case sensitive, and so if the names of your variables are lowercase, you shouldn't put them in uppercase because it won't recognize them. Now, when we looked at the names output earlier, we saw that they were all uppercase, so I have to use uppercase letters. But in your case, if you have lowercase letters, you can just use those. But the key point is that they're case sensitive. So if it's lowercase, keep it lowercase. If it's uppercase, keep it uppercase. Okay, so what we're going to do is we're going to take the data frame data set that we created up at this stage, and we're going to refer directly to the variable sex. And we're going to use the asNumeric function to create a numeric variable that's basically a numeric version of sex. It's going to be coded basically 1 or 2. And we're going to create a new object, which actually is going to overwrite the existing object, called dataset sex. Right? So basically, this will take this variable sex in the data frame dataset, run it through the asNumeric function to create a numerical version of it, and it's going to save it as the same name. So I'm just basically overwriting it, and I'm going to be calling it dataset sex. Now, I'm not actually going to run this because, like I said, mine is already numeric, but yours might not be. So if you find that you're getting errors because of numeric operations, go ahead and convert it to a numeric variable before you run it, and just overwrite it so it has the same name. Okay, one other command that I want to show you that will also be very handy for looking at the raw contents of a file. It's the head command. So the head command basically shows you like the first couple of observations of some kind of object. And so in this case, I'm going to run the head command on the dataset object, our data frame that shows all our data. And so if I just highlight this and I run it, and then if we just kind of look at our output window, we can see that after this file was run, the output shows basically looks like just 6 observations for each of the values of the variables, right? So head just showed us kind of the first couple of observations. So you can see there's numeric codings for each one of these variables. So we have an ID variable that's valued 1, 2, 3, 4, 5, 6. We have some values for the number of children, the respondent's age, their education, their father's education, the highest degree earned, and so on, right? So all of these variables will have numeric codings, and we can look at that numeric coding with something like the head command.